So let's jump into the area under a curve. I've got notes here. Previously, we've already talked about estimating areas under a curve with rectangles. We've used geometry to also calculate areas under a curve. We've made a link between definite integrals and areas under a curve. We did that in fundamental theorem of calculus. And we practiced calculating definite integrals using antiderivatives. So we're now going to bring it together to calculate the exact area under a curve. So if we have f of x is positive, which means if this function f of x here sits above the x-axis, so that just means the numbers in it are positive, and it's continuous, which means we don't have any asymptotes. It continues the whole time. We've got a full domain. On the interval a is greater than or equal to x greater than or equal to b, so we've got our a and b value. Then the area bounded by our function, the x-axis and the vertical lines x equals a and x equals b is given by the area equals the integral from a to b of f of x dx. Or now, I'm going to suggest we start using this notation. I've seen it in someone else's notes and I quite like it, that we start specifying our variable here. So here we've got x equals a. We just do it on the bottom one to specify that where our bounds are set in terms of x at the moment. So let's see this in practice. So find the area of the region enclosed by y equals 2x, the x-axis x equals 0 and x equals 4 using, the first one is geometric argument. So we're going to come up with a little checklist at the same time of how we would solve these. So the first thing we want to do here is, I'm going to write this as checklist. We're going to want to sketch a graph for any method. We want a quick graph here, so sketch, graph. So I'm going to quickly go over here and it doesn't matter too much how you draw your graph, but realistically you've got a graphics calculator, so the graphics calculator will give you shape and important features. So this graph here, we've got 2x, y equals 2x is just going to go up from the origin, up at a value of 2. I'm not going to do it to scale, just purely based on the fact we know it goes through the origin, we know it's a linear function. If I do it to scale, it won't work. We've got x equals 0 here, and then our next one, x equals 4. Let's just come over here, x equals 4, and this would come up, I haven't drawn this sketch the best, this would give us a coordinate of 4, and we put that into 2, 8, 4, and 8. I'm just doing that so we can sort of work out the shape, and then that is it. That's everything's enclosed in that space. Now, a geometric argument means you can see the shape this is. I'm hoping you can identify that this area in here that we're calculating is a triangle. So it means that we're going to have here our area, and I'll use the integral notation. X equals 0 is our lower bound up to 4 of 2x dx is going to be equal to a triangle, because that's a shape. We've got base times height over 2, which means our base here is going to be 4 units long. And our height here is going to be 8 units. Now, it's not quite drawn to scale, so we're going to have 4 times 8 divided by 2. Okay, 8 divided by 2 is 4. It's going to be 4 times 4, which is 16 units squared. Okay, pretty simple that one, but that's a good example for us. But our second part says, let's figure it out using our integration method. So I'm going to duplicate this because we already wrote the integral because we're in good practice. So now to solve this, what we do is we go, well, the next step here, previously, I'm going to sort of write the two. We would say that this is f of b minus f of a, and that's how we sort of did it. But in our last chapter, we introduced a new notation. I'm hoping we're using that comfortably now, that we would use this box and we put our bounds on it. We've got x equals 0, we've got 4 up here, and we now take the integral. So we put f of x in here. Okay. I'm going to erase that purely based, I want you guys to we want to have that I'll write it up the top here. I'm going to write f of x up here just so we know. I don't want you to have to do it every time to put it in this. So we've got our 2. We're going to have, this is going to be 2, and then I've got my antiderivative of x is going to be x squared over 2. They're going to cancel, and we get, I'm just going to write that up there, so we've actually got that as well, which equals x squared, so we understand where that came from. So now our next line here, we've got our f of b, we do our top bound minus our lower bound. So we've got here 4 squared minus 0 squared, and that's going to equal 4 squared, which equals 16 units squared. Now, I'm going to point out here that depending on the question here says find an area, that's why we've got units squared, and we need to make sure we always have units. But if it was asking for us just to evaluate an integral, we wouldn't do that. Now, so we sketch the graph. We need to find, no, I don't actually need the checklist yet. We're going to use the checklist in the next bit. Actually, I will always suggest sketching graphs for an integral, and areas must have units squared. Now we're going to add complexity to this in the next bit. Our final bit here would be to check with our graphics calculator. So grab your graphics calculator out, and you're going to graph our function, which is 2x. So if you put in your calculator here, you go menu, graph, I'm going to write check GC, graph. We've got y1 equals 2x. So I've just put that in my calculator. I've drawn my function, and then we go G solve f6 integral dx, and then we've got lower equals 0, upper equals 4, and in my calculator it's then given me that this equals 16. So we've got a big tick there. What do we got? 2 more. So find the area of the region enclosed by y equals x squared plus 1, the x-axis x equals 1 and x equals 2. So if I'm considering this, we're looking at this function here, x equals 1. What do we got? Our other one is x equals 2 would be here. So that's 2. I'll just highlight that. So looking at doing this by integral methods. So our area, because it says find the area, we know we're going to have units here. So we're going to do area equals the integral from 1x equals 1 to 2 of x squared plus 1 dx. Okay, so next step here, we're going to do the antiderivative to figure these out. We've got an upper bound of 2 and 1. So the antiderivative of x squared is going to be x cubed on 3, and 1 just becomes x. So my next step here, I'm going to put my answers in. So I've got 2 cubed on 3 plus 2, close bracket, minus 1 cubed on 3 plus 1. Okay, this is going to equal 2 cubed is 8. So I got 8 on 3 plus 2 minus 1 on 3 plus 1. So that's going to be 8 on 3 minus 1 on 3 is going to give me 7 on 3. And then 2 plus 1 is 3, so I get 3. So this is going to be 7 on 3 plus 9 on 3, because that's what 3 equals. gives me 16 on 3, which is 5. And a third I've stuffed up here. Where have I stuffed up? 8 on 3, 2. I've stuffed up here with this negative. That should be -1. So I didn't expand this bracket properly. So that is a bad mistake. So this here would be 1, which means this would be 3 on 3, which means this is 10 on 3, which is 3 1/3, and that's an exact value. And we should know that when we put this in the calculator, we're going to be looking at 3.33. So let's just quickly check this with our graphics calculator. So I'm just going to quickly graph it. What do we got? X squared plus 1. So press G solve, integral button, select my graph. Lower bound is 1, upper bound is 2, and I get 3.33. So graphics calculator, check. Now I don't have units squared, so I need to put that in, units squared, because that's a... There we go. So final one here, we've got a trig one. This is one of the harder ones. So find the area of one arch of the curve sine 2x and the x-axis. So we sort of need to know our function here. So let's just think of, if I think of sine, I'm going to use a different, I'm just going to pick theta here. We need sine theta equals 0 because that's going to give us these points here. And so sine theta equals 0 when theta equals 0 or theta equals pi. Now we have, that means 2x, therefore 2x equals 0, x equals 0, or 2x equals pi, x equals pi on 2. Now the reason I've done it that way is if when you put this in your graph, because remember the first step is to sketch your graph. So we put this in, so sine 2x, and when I draw it, I've got my function, I go I've got so many functions, G solve roots, and I get 0, and then my next one gives me 1.57. Now, you might know 1.57 is pi on 2, but this is an exact value, and I've shown how to get it exactly. Okay, so this step here is really important because the next thing, when I calculate the area of one arch, it's going to be from x equals 0 to pi on 2 of sine 2x dx. Now, this particular one, let's practice with our substitution. So we would be looking at u equals 2x, which means du dx equals 2. I need to get a 2 in here. So I'm going to go area equals a half. I'm just going to multiply that outside. X equals 0, pi on 2, sine 2x. Okay, I'm just going to close that bracket around it, and then that's going to be times by 2. Now, because I put the half in here and the 2, they multiply and give me 1, positive 1, so it hasn't changed my function, and that's dx. Now, we're just going to quickly point an arrow here. This is our du dx. This value in here is our u. So our next step now is going to be area equals 1/2 integral x equals 0 pi on 2, and this is sine u du dx, so it just becomes du. Now, it's up to you how we go here. We can either, I will do both methods again as a practice, so let's just do it without changing the variables. Let's leave them as x, so area equals 1/2. We've got our box here. The derivative of sine is cosine, and it's derivative. Let me just check my integral rules to check I'm not. It's negative cosine, so negative cosine here. So we're going to have negative cosine u, and we've got x equals 0 and pi on 2. Okay, so as we said, one way to do it is now I go cosine, I resub my u back in, it's 2x, and I've got x equals 0, pi on 2, and so to solve this answer we get half, bracket, cosine 2 times pi on 2, the 2's are going to cancel, I should put a big box around that, minus cosine 2 times 0, and I'm just going to close that out. Now this one here, actually I should use a bracket, it looks a bit like the step before it, so I'm just saying that this half is multiplied by everything in here, so we get half, cosine pi is -1, so cosine pi is -1, cosine 0 is 1, so it's -1 here, which means we get half times -2, and I have stuffed up here somewhere because I've missed that negative up here. Sorry guys, that's my bad. So that means that's a negative. We've got a negative here. That becomes a plus because of... Now, the reason I knew that was because I got a negative value here. You can't have a negative area for this particular one. So that becomes plus. Oh, hang on, let me write that out as another step. Sorry for making that mistake. So we've got here, this would be the negative sign, and then cosine pi is -1, and then this one here would have been +1, which would have given us 2 here equals an area of 1. Now, you can leave it there if that's the method you do. If you don't like swapping the variables, we can, if you don't like doing this change back, we can change them into u's. So here we've got when x equals 0, u equals 2 times 0, which equals 0. The other one is when x equals pi on 2, u equals 2 times pi on 2, which equals pi. So this next step here would be the area equals bracket negative cosine u, and then I swap these values out for the, so when our lower bound equals 0, it equals 0 still. So now we would have u equals 0, and then I've got u equals pi here, which means I get to an area, I've missed the half out the front. Gosh, I'm making a lot of errors. So this would be half, take cosine pi, and then minus cosine 0. Now, I'm just going to point this out just because I've made a lot of errors here. Something to consider, this constant here, when I get to this point, I could actually pull this out because it's going to be in both my answers. It just saves me the double negative here. Like if I had pulled this out earlier, so if I'm going to do it in this example to the right. Let's just, so if I was to redo this, just from what I've shown you guys just then, let's duplicate that. I'm just going to change it a little bit. If I move that out the front here, this would become area equals -1/2 there. Okay, and it just means that in here, I can get rid of a lot of this, and this just becomes this value here, and I get -1/2, and then cosine pi is just -1, and then it's take 1. Okay, and that ends up being -1/2 times -2, which equals 1, equals +1. 1 units squared. So either of those is fine. I've just tried to do both of them so you get to see them. I'm going to leave that investigation for another video. So that's it there.